have. Now let's look at them. First, we'll talk about the dimensions. So what is dimension? It's an abstract concept. Dimension is an abstract concept, right? And it is not attached to any unit or any scale, right? So for example, if I said that, look at the circle, the perimeter of this circle, the length of this line, height of this boy, and the diameter of this soccer ball. What's common to all of them? All those physical quantities, different from each other, have same dimension, the dimension of length. So dimensions, which is an abstract concept, are very few. There are not too many base dimensions, fundamental dimensions. So fundamental dimensions that we deal with are mass, and we write it usually as uppercase M, the length, uppercase L, time, uppercase T, current, I, and temperature, theta. There are only very few base dimensions. Rest of the physical quantities, they can have what are known as derived dimensions, which are dependent on the base dimensions. So for example, area. Area has dimension of L square, L times L. Volume has L cubed. Velocity has length over time, right? L over T. And acceleration is L over T squared. So when I say analyze something from a dimension point of view, don't use units. That's very important. I've seen students making this mistake because maybe this is how you did things in your high school classes or some other classes. When I say analyze something from a dimensional point of view, use M, L, T, I, and theta as a symbol to do the analysis. Don't use kilogram or meter or pound force or feet to do the analysis, okay? Because then you are picking a unit. So these are all derived dimensions, right? But then there are quantities that are dimensionless. Mach number. What's Mach number? Anybody? What's Mach number? A multiple of the speed of sound. Anybody else? What's Mach number?
The speed of an object relative to the speed of sound.
So it's the ratio of the speed of an object moving through fluid and the speed of sound, right? So since you have the speed in both numerator and denominator, it's a dimensionless quantity. It has no dimension whatsoever. You have a ratio. What about angle? Is angle a dimensionless quantity? Yes? No? No? What's the definition of angle? What is the definition of angle? Anybody? How do you define an angle?
If two straight line meets in a certain point and create.
Anybody knows the definition of angle? Radius? Sorry? Radians? So radians are one of the units, right? So if you attach unit, does it mean that it's a dimension quantity? Well, it turns out that actually radians is not a unit. Degree is not a unit for angle. They're not units. So you may have been told that they're actually units, but they're not units. Right, so what she's saying is that maybe it has something to do with the arc length and the radius, right? I'm hearing all the right words. So angle is really nothing but the ratio of the arc length and the radius, right? That's what angle is defined as. So if I have an arc length, let's see if I can use this. If I have an arc length, right, then the angle it subtends at the center, theta, is equal to the arc length, which is S, divided by the radius, right? So if you look at this definition for the angle, which is the ratio, numerator and denominator both have the quantities which have dimension length, which means angle itself is a dimensionless quantity, right? So if you're looking at the total angle subtended by the whole circle, the perimeter is 2 pi r divided by r, so that gives you 2 pi, right? This is your high school definition of the angle. Or you may have seen the definition of the arc length that can be computed from the angle and the radius. So angle is also a dimensionless quantity, and contrary to what you may have thought so far, radians and degrees are not the units, because units are something that you attach with a quantity that has dimensions, right? What about trigonometric functions? Sine of something, cosine of something. Do those quantities have any dimensions? No? Why not? Because they're ratios. So if you want to define sine of an angle is defined by, in a right angle triangle, just a simple example, if this is D, this is L, then sine of theta is D over L, right? And that's a ratio. D over L is a ratio. D has dimension of length, L is also a length, so Trigonometric functions also are dimensionless quantities, right? So there are quantities that have dimensions, there are quantities that have no dimensions, and if you know their basic definition, you can find out what they are.